So today we are going to see experiment called addition and subtraction using half order and full order. Okay, so we are going to add two binary numbers. Binary numbers we know, right? So 0 and 1. Okay, so here is a truth table. So then there will be a pin diagram, then there will be a circuit diagram. So everything you need to draw in your observation. So this is called a pin diagram. Okay, then the result must be in the last page. So this is how you have to write the observation. This is a digital IC trainer kit. These are the IC chips, also called as integrated circuits. Okay, so this is our diagram for our half order. So let's see how to do the experiment. Okay. Trainer board, you can see the power supplies. So white thing is called board. In the whiteboard only we will be inserting our ICs. So it will have the green color. So the green color are inputs, the red colors are the outputs. So there will be 10 outputs, then also 10 inputs. So you can see their logic input, right? So there will be switches. Okay, so in order to get input and output, okay, I will tell you that how to do that. So you can up portion is called 0, then down portion is called 1. So there will be a plug connection behind the board. So you can see that there will be a switch to connect with the power source. You can use that plug. So there will be a switch. You switch on the system means, so switch on the system means you can see the lights getting switched on. So the system is on now. These are the IC. We need to fix it on the whiteboard. Before fixing the IC, we need to switch off the system, because sometimes you may get kind of shock system, then you can fix it. So fixing will be like this. Okay, you can see the line, right? So there is a line path is going on, right? So the IC engine must be fixed one in that in this like this. Okay, so I hope you understood this. Center of the board, okay, should be like this. Okay, so there should be a path in between. Okay, so in IC engine itself you can see the numbers. Okay, so then and also there will be a cut. Okay, there will be a cut at the left side. Okay, so that must be in the left side. Okay, so you have to fix the IC like that only. So if you are fixing it the wrong direction means there's a problem. Okay, you won't get output and all. So you can see the cut here. Okay, in starting of the IC you can see the cut, right? I'll show you. Okay, wait, I'll show you. Okay, after fixing the ICs, okay, you can give your connections as per the circuit diagram. Okay, so here you can see the cut, right? There is an arc here, right? Okay, so the IC must be fixed in that way. Okay, so you can see the number also 7408. Okay, 7486. Okay, so these are the IC number. Okay, each IC is integrated with logic gates. In that 7486 you can see it is integrated with XOR gates, as well as in 7408 it will be integrated with AND gate. Here you can use piece of wires to give the connections. So here I am going to give the first input with the first pin of 7486 as per the circuit diagram. So you can see the first A is connected to the first pin of 7486. So this is my first input A. So if you opening it, you will see one hole. So insert the wire in the hole, then you can close that knob. So the first input is given to the SUM486. Make sure your circuit board is in off position. So the first, you can see this, right? First pin is connected to the A. The second input is B, so it will be connected to the second pin of SUM486. So the red color is our second input, is called B. So I need to connect with another wire from B to the second pin of SUM486. Second pin of SUM486. So you can see that, right? So there are 5 holes, right? So you can connect in any holes. The first IC is over. So here is our second IC, is called SUM408. That should be connected to the A and B, but I can't directly connect to A and B. So what I'm going to do, I'm going to interconnect with the XOR gate, that is our SUM486. In the diagram you can see the first pin connected to the B and the second pin connected to the A. So the first pin of SUM408 should be connected to the B. You can't connect this IC with the B directly, so instead of that, the another IC SUM486 is already connected to the B, right? In the second pin, so you take a wire. The second pin is connected to the B, right? So you can connect with the second pin instead of connecting with the B. Now we are going to connect the second input with the SUM408. So instead of that, it's the same method. Okay, so the another IC already connected with the A. So take a wire and where it is connected with which pin is connected with the A, so you can connect with that pin. Now both the ICs are connected with the input A and B. Now we need to give the output. So in that circuit board you can see the red color buttons are there, right? So these red colors, so those are called outputs. So okay, so in both IC, the third pin is your output. The first output is our sum, where you are getting from XOR gate. So okay, the third pin of XOR gate will be connected to the sum output. Okay, so this is our SUM408 IC. If you are taking the output from the SUM408, that is our carry. Okay, so this output is called as carry output. So here I'm taking another wire. I'm going to take a connection with the SUM486, that is another IC. Here I'm going to take another wire to give the second output. In the circuit diagram you can see the output which is coming from the SUM486. Your SUM486 is your sum output. So in the truth table you can see sum and carry and all, right? So now the output connections are done. Now we can give the ground connection and voltage connection from each IC. So I'm taking another wire and I'm going to take the 14th pin of each IC to the voltage. So the black color is here, the black color is our ground. So ground connection must be given to the 7th pin of each IC, but you can't connect directly with both IC in ground connection. What I'm going to do is, first I'm going to connect directly with the 7th pin of one IC. So take another wire from the 7th pin of that IC to the another 7th pin of another IC. So the ground connection is done. In the pin diagram you can see the 14th pin is connected to the voltage and the 7th pin is ground. This connection only we have to give it in the end. Okay, the 7th pin I am giving to the ground. take another wire. So the 14th pin is another side of last pin. So this is our 14th pin. I'm connecting with the voltage. So here we are using 5 voltage. We have successfully connected the ground and voltage with the one IC. Now we have to take another wire and you have to connect the another IC with the ground and voltage, but not directly. So I can interconnect with the another IC. So take the wire, so 14th pin from the another IC to the 14th pin from the this IC which is connected to the voltage. So the voltage is done now. The same thing I have to do for ground connection. So take another wire, so from the 7th pin of that IC to the 7th pin of this IC, so the ground is also done. Now both ICs are connected to the ground and the voltage. Now you can switch on the digital circuit board. So you can see the lights, right? Now you can check with the truth table whether you have connections are correct or not. So this is a truth table of half adder. So in the table you can see A and B are the inputs and the outputs are sum and carry. So the first input values are 0 0, so the output should be 0 0. Let's check. I told you the inputs are 0 0, right? So the inputs are 0 0 means should be off. So if your that light is on means that is 1. Okay, so now the inputs are 0 0 condition only. So 0 0 means the output, there is no light from the output, so the outputs are 0 0 only. Okay, so the first rule is satisfied, that is 0 0, the sum and carry are 0 0. 0 0, sum and carry are 0 0, sum 0, carry 0. You can see inputs are 0 0. Okay, so it is in off condition means 0. Okay, so 0 0, outputs are 0 0, 0 and 0, 0 and 0, right? 0 0. Okay, the yellow color is our carry, yellow color output is our carry, and the green color output is our sum. So the next input I am going to give 0 1, the sum should be 1 and the carry should be 0. So 0 1. Okay, so first is 0 only, so second I need to switch on that. So 0 1, the sum should be 1 and carry should be 0, right? So check with the output. So 1 0, right? So sometimes you may not get correct answers, so what you have to do is you have to just check the wires. Now we have got the answers 1 0, that is sum is 1, carry is 0 as per the truth table. So second is satisfied. So the third input is 1 0 1 0 1 0, right? So sum must be 1, the carry is 0. Okay, so 1 0, so 1 0, so I need to make it 1, so here it is 0. So the sum is 1, carry 0, so the third rule is also satisfied. So coming to the fourth one, so 1 1, so the sum should be 0, the carry should be 1. Okay, 1 1 means another I have to switch on, then sum 0, carry 1. Okay, check with the truth table, 1 1 0 1. Okay, so all the rules are satisfied now. Now I'm coming to the second operation, that is half subtractor. Here extra IC I need to fix, that is our 7404. So that is the integrated NOT gate. So as per the circuit diagram, so the A and B will be connected to the XOR gate only, but the second pin of XOR gate should be connected to the first pin of NOT gate, and second pin of NOT gate should be connected to the first pin of 7408. Here the NOT gate is nothing but 7404. Okay, so this is a truth table. So 00 should be 00. Okay, so this is our NOT gate, you can see. I hope you can see, but no problem if you can see the numbers. That is, the number is 7404. So you can connect the NOT gate with wherever you want, but the connection should be same as the circuit diagram. So from the circuit diagram you can see the XOR gate. Okay, the second pin of XOR gate should be connected to the, okay, here is a first pin of second pin of XOR gate should be connected to the first pin of NOT gate. Okay, before that what I have to do is I have to disconnect this wire, that is the second pin to the first pin of AND gate, right? So I have to disconnect it. So I am taking off the wire and connecting with the NOT gate. Okay, the second pin, right? So the second pin of XOR gate should be connected to the NOT gate first pin. Then the second pin of 7404 should be connected to the first pin of 7408. Okay, so I'm going to give the second connection here from the NOT gate, that is 7404, second pin to the first pin of AND gate, that is 7408. So these connections must maybe confusions for you, but it is very easy when you are connecting with use of circuit diagram. Okay, then the ground connection and the voltage connection as usual. So I am connecting the 7th pin of 7404 to the 7th pin of any IC, okay, which is connected to the ground. Then the voltage connection, which is from the 14th pin of 7404 to the any IC of 14th pin, because all those ICs are already connected with the ground and voltage, right? Now everything is done here. Okay, what I have to do is, now the connections are done, what I have to do is I have to check with the truth table. So same input and output, sum and carry. Now it is our truth table for half subtractor. Okay, the first input is, now I'm doing simple check with the use of truth table. Okay, then I go for the full checking because the connections may be loose, right? Here is a truth table for half subtractor, so including NOT gate. So first input is 0 0, so the difference and bar should be 0 0. So here instead of sum and carry we have a difference and bar. Okay, let's do it. So here you can see first input should be 0 0, right? So make it a 0 0, so the output is also 0 0. Okay, so the first rule is verified. The second rule is 0 1 1 0, right? So 0 1 0 1. Okay, so the output should be 1 0 1 0, right? So 1 0. So the second rule is also verified, so make a tick. Then 1 0, the input is 1 0, the output should be 1 1. So 1 0. Okay, you can see the two lights are on, right? So that is 1 1 1 0 1 1. The last rule is 1 1 means I should get 1 1 means 0 0, right? So 1100. Now we are satisfied all the rules. Okay, the experiment is done.